I know what you're thinking. You're thinking we're talking to a soil scientist. And you're thinking, yeah. You know, what's in the dirt? You know, I get it. No, you don't. Because this guy comes in here and I'm thinking, okay, soil scientist, yeah, I got it. And I start talking to this guy. I'm like, wow, really? Ladies and gentlemen, welcome to the program, Dr. Theo Udeigwe. How are you, man?
Thank you.
What exactly does a soil scientist do?
Well, the soil scientist in general, just as the name implied, soil is someone that studies, more of the soil, of course, anything below on the surface. So a soil scientist, or the profession of soil science is actually broad, because the soil contains a lot of stuff, and it cannot be studied just by one person. There's a physical aspect of the soil, there's a biological aspect of the soil, and also the chemical aspect of it, which is the one that I'm looking at. And each of these fields is studied differently. You're gonna have a set of applications or instruments applied to each of it. So it cannot be covered exactly or covered comprehensively by one person. So that's why we have different specializations. So
and your specialization is mainly chemistry.
Yes.
Involved in the soil.
So my specialization is more of the chemical component of the soil. So when we're talking about the chemical component of the soil, we are looking at things like, for instance, the pH, which is known by everyone, which is like more of the degree of acidity or alkalinity of the soil, pH. We're also looking at something like organic matter content of the soil. We're looking at the electrical conductivity of the soil, which has to do with salinity, how much salt it contains. So all these are examples of the chemical properties of the soil. So these are the kind of things that we are looking at.
Okay, now, some of the physical applications that are implicated here are obviously, from an agricultural standpoint, what types of things and what types of soil there are and how things can be manipulated to make things grow better, maybe more drought tolerant, et cetera, all these different things. And I get that. Another aspect of what you do is kind of international. Now, you reach out and you do these things with other countries.
Right.
Yes. What are you involved in right now?
We have stuff going on with different people, different parts of the world. Like, for instance, I have something I'm doing with guys in China. This summer I just came back from Kenya, that's in East Africa, where I went there to, look at some research, look at possible ways of collaborating with some scientists over there, also helping teaching some graduate students. We have something going on in Jordan. Some part of Jordan that's in the Middle East, they have soil that have similar characteristics with the kind of soil we have here. So I have a colleague there that we are looking at heavy metals. Heavy metals, for instance, would be something like zinc, copper, lead. So at high concentrations in the soil, these are not really too good. So we are looking at what we do that affect their fate in the environment. And, we have to understand their chemistry in the environment in order to understand how to remediate or, plan a remediation program. You got to understand the chemistry of these elements. So these are some of the international programs that we have. And also in somewhere in Ghana, we have something going on in Ghana that we look at heavy metals as well, how it changes on the landscape. Heavy metals, for instance, zinc, copper, and so on. And we have something that we did with someone in Egypt. That's more of climate change issues and so on.
Right.
So we just, spread all over.
Okay.
So,
Wow.
yeah.
So if we're talking soil remediation and things like that, so that's kind of relative to, and you can actually, let's say, if there's a hazmat spill or something that's in the soil or has been spilled in the soil, you really can't remediate or try and fix that until you know exactly what's in it. So basically, you break it down to the elements, and so you're no stranger to the periodic chart.
Exactly. We're not. We're not strangers to periodic chats. So, yeah, as Tom said, for instance, in this area, we have issue with our groundwater, for instance, and there are studies showing that
Or the lack of it.
yes. Studies showing that as the level of the water is decreasing, also the contaminants they are increasing. For instance, arsenic, for instance.
So as the water level in the aquifer goes down, the contamination is going up.
Contamination is going up. So what happens is that the work of the soil scientists there is that, as this water keep on being pumped on the surface, yes, we also increasing the contaminant level in the surface. All right. So where do this contaminant be? Like now, you have a contaminated soil. The contaminants can be tied to clay, for instance. It can be tied to organic matter. It can be tied to different soil constituents. And you have to know where this is tied in order to remove it if you are designing a remediation program, for instance.
Okay. It is 7:21 with Tom Collins, Laura Mack. This is Lubbock's First News in conversation with Dr. Theo Udeigwe. He is from Plant and Soil Sciences. Actually, he's from Nigeria, but he is currently at the Plant and Soil Sciences Department, Texas Tech University. Imagine that. Hey, man, thanks for hanging out with us this morning. Okay, normally these Plant and Soil Sciences people, like, Joey Young, he lines a lot of this stuff up. Normally they're just sending, pretty faces in here. Not just kidding. But this is interesting because, I've never had the opportunity to sit there and talk with somebody that is a soil chemist or a chemist, and realistically speaking, you are involved in environmental kind of forensics. So it's all relative. Now, I don't think that they're going to do a PSSCSI, television series about, soil science, because it's, people don't think it's that dramatic. But the thing is you can take a chip of plastic off a telephone and tell me what it's made of, right?
Yes.
Which brings me to my next question. If I brought you a bucket of Kentucky Fried Chicken, could you tell me what those 16 herbs and spices are? You could, couldn't you?
I will try and tell you the elements that are composed, that contain in the chicken. I can break it down and tell you. This
that would be a definite maybe.
Well, not to mention Bush's bean recipe, too.
Yeah.
Yes, I can break it down and tell you the elements that are contained there, are responsible for the flavor there. Yes.
Well, you said that you guys were doing or helping with some research in Egypt that involved climate change in the soil. What are your studies involving climate change?
Climate change is, of course, it's a global issue, and different parts of the world feel it differently. So sometime last year, I had a fellow from Egypt who came in, and the guy was, he's a soil scientist, but he's interested more on how climate change is affecting agriculture in general. And with a soil science background, we started looking up literature and stuff on that, on relating in general, how this climate change affects agriculture. And it may not directly affect the soil, like change the composition of the soil, but it may affect the variables, like, for instance, temperature, precipitation, that's rain, and all those other things that can, if they are changed, they will, indirectly change the chemistry or the physical properties of the soil. So directly may not just, change the soil color or so that nature, but, temperature change, water change, and so on, that will indirectly impact, the soil. Right?
Okay, now this is probably more complicated than, my mind can handle. I'm going to ask you this question. You were talking about heavy metals and zinc and things like that are in the soil. And, or water, and water changes that. But, then I'm kind of thinking, I don't know if you've ever seen the movie Aaron Brockovich, but the thing is, in that movie, there was the presence of hexavalent chromium in the water, which contaminated the ground and the groundwater. Now, how in the heck do you make a remediation plan to get stuff like that out of the water and out of the ground? Can it really be done like the EPA? They just recently had this, gazillion gallon chemical spill in Colorado. And then they said, well, it's clear. Well, maybe it is now, but it's rolling downhill somewhere. Can you ever really just get rid of something like that? I don't think you can you?
Yes, to an extent, you can reduce the level to a limit that is not going to be too harmful to humans or to environment. Yes, you can do that. You can reduce the level. Yeah, you may not completely get rid of it, but bring it down to a level that will not be so harmful. In terms of the chromium you're talking about, which is not one of the desirable elements for human or plant. That's where the soil scientists come in, because the soil scientists can understand the chemistry of that pollutant in the soil. If you understand the chemistry, basically you understand if that pollutant drops into the soil, where is it going to be? Because the soil is still complex. It's complex. So that contaminant is going to be tied up somewhere in the soil. And for you to design an effective remediation program, you're going to know where is it tied up. Is it tied up more to the clay? Is it tied up more to the organic part of the soil? So this is where the soil scientists come in. In most cases, when it comes to remediation, some clay materials, some materials that contain high amount of clay, we have high sorption capacity for those contaminants, those heavy metals, for instance. So a material that contains clay, like a clay material, can be used or dumped into that soil. Then it's going to sorb onto those chemicals and hold them. Then you're going to find a way to remove the clay. So by doing that, you are removing the contaminant.
Sounds like a $high project to me. Yeah. What about you, Lori?
Yeah, there's a story out just today about uranium being in our aquifer.
Yikes.
So, is there anything soil scientists can do to help with that situation?
Yeah. Yes, if it's in the aquifer, that means as you're pumping water out from there, it's going to be in the soil. And that's a radioactive material. So the soil scientists, that's where the soil scientists come into play as well. Because the level in the water, it may be really too bad, but maybe it may take a while to really accumulate in the soil in order to be harmful.
Right.
So that's where the soil scientists will come in, and at least it starts with quantifying how much we have there. Mm-hmm. When you quantify how much we have there, then you're going to look at some basic things to understand the chemistry of that particular element, the uranium, for instance. If you understand the chemistry, then from there you can start designing a remediation, techniques. Sometimes what you need to know is, like, for instance, what has an affinity to attract this. Mm-hmm. For instance, is it a clay or is it an organic compound that will attract this? So if you know what has an affinity for that, that gives you an idea of what you can use to remove it.
Right.
Something.
Well, I am glad there are people like you that understand the chemistry of all that. Yeah. I certainly don't.
Interesting conversation, man. I could sit here and talk to you for hours. Dr. Theo Udeigwe, Texas Tech University Plant and Soil Sciences Department. He's a soil chemist.
Thanks for coming in.
And we're going to see about getting you a bucket of Kentucky Fried Chicken. Break that down. Hey, we'll talk to you again, yes?
Thank you.
All right,
yes,
thank you, man.
Yes, thank
Appreciate
you so much.
it.